Leader election, the heartbeat of distributed systems, techniques, algorithms, and real-world applications.
Have you ever wondered how distributed systems stay coordinated even when managing millions of users and complex workflows? The secret lies in leader election, a crucial process that ensures systems run smoothly and efficiently. In today's video, we'll dive into what leader election is and why it matters, popular techniques and algorithms used for leader election, and real-world use cases where leader election plays a pivotal role. Stick around because mastering this topic could be your ace in system design interviews or your next big project.
Leader election is the process of selecting one node or server in a distributed system to act as the coordinator or decision-maker. This leader handles critical tasks like managing resources, synchronizing data, or resolving conflicts. Without a leader, a distributed system can fall into chaos, with nodes competing for resources or failing to act cohesively. In essence, the leader is the brain of the system, ensuring that all parts work together seamlessly.
Now let's talk about how leaders are elected. Here are some of the most popular techniques. Bully algorithm. In this approach, nodes compete to become the leader based on their unique ID or priority. The node with the highest ID becomes the leader. It's simple but prone to high message overhead in large clusters. Raft consensus algorithm. Raft ensures safety and fault tolerance by holding elections through majority votes. This algorithm is widely used in tools like etcd and console. Paxos, a more complex yet highly fault-tolerant approach. Paxos ensures consensus even in environments with unreliable nodes or network partitions. ZooKeeper's ZAB protocol. Used in Apache ZooKeeper, this protocol provides leader election for managing distributed systems effectively. Each technique is like picking a captain for your team. Do you prioritize speed, fairness, or reliability?
Leader election isn't just a theoretical concept. It powers some of the most critical systems today. For instance, in database replication, leaders coordinate read and write operations in distributed databases like MongoDB and PostgreSQL. Then, there's distributed locking, where leaders manage resource allocation in systems like Redis or ZooKeeper. And let's not forget cluster management. Tools like Kubernetes rely on leader election to maintain the state of the cluster and schedule workloads. Without leader election, these systems would struggle to maintain consistency and reliability.
Of course, leader election isn't without its challenges. Network partition. What happens if nodes can't communicate? This can lead to split-brain scenarios with multiple leaders. Then there are node failures. Systems must handle leader failures gracefully to avoid downtime. And let's not overlook latency. Election processes can slow down the system if not optimized. The key to effective leader election isn't just picking a leader, it's ensuring the process is fast, fault-tolerant, and reliable.
Here are some best practices for implementing leader election. First, use consensus algorithms like Raft or Paxos for high-stakes environments. Second, implement timeouts to detect leader failures quickly. Third, monitor and log election events to debug issues proactively. And finally, always design for failover to avoid single points of failure.
Here's my pro tip. Combine leader election with robust monitoring and fallback mechanisms. Use tools like ZooKeeper, etcd, or Kubernetes to simplify implementation and focus on scaling your system. And remember, leader election isn't just about efficiency, it's about resilience in the face of failure. In distributed systems, the best leaders aren't chosen, they're engineered.
To recap: 1. Leader election is essential for managing distributed systems. 2. Popular techniques include the bully algorithm, Raft, Paxos, and ZooKeeper's ZAB protocol. 3. Real-world use cases range from database replication to Kubernetes cluster management. In our next video, we'll explore consensus algorithms, Paxos versus Raft. Don't miss it!
If you're ready to take your system design skills to the next level, hit subscribe, turn on notifications, and join me for the next episode. Because great systems don't just run, they lead the way.
Subscribe to Hustler Coder Leader Election Made Simple Techniques and Use Cases, new videos every week.